All right, in this lesson, we're going to look at linear equations. So, the official definition, or a definition, is a linear equation is one that can be written as ax plus by equals c, where a, b, and c are real numbers, and a and b are both not equal to 0 simultaneously. A, b, and c are real numbers, and a and b both can't be 0. So that just guarantees that this last one, that a and b both can't be 0, guarantees that you have a variable term. Because if a and b were both 0, then you get 0 equals c, which you don't get anything, you don't get an equation there. For example, if we had 3x plus 4y equals 12, that would be a great linear equation. They're called linear equations because when we go sketch this graph, we're going to get a straight line. And so you could do, if we wanted to sketch the graph of this equation, we can do a table where we're picking the values for x and going to figure out what the y values are. And if we're doing this, I'm typically going to pick right around 0, like from -2 to 2. So I plug in x equals -2. Then I get -6 plus 4y equals 12. So 4y equals 18. So y would be 9/2. Not a nice point, but a point. Similarly, if we plug in -1, 3 times -1 plus 4y equals 12, we'd have 4y equals 15, so y equals 15 over 4. If you plug in x equals 0, you get y equals 3. And we're going to get uglier answers. This is going to be 9/4. I'm going to leave these calculations to you. This is going to be 3/2. If we skip to 4, then y turns out to be 0, because if we plug in x equals 4, we get 12 plus 4y equals 12, so 4y equals 0, so y is 0. Okay, well, these 2 points that I quote-unquote happen to find, 0, 3, and 4, 0, are going to be the x and the y intercepts. So, let's just define those, and we'll sketch the graph of that line. The x-intercepts, they're always going to look like some number, comma, 0, because we're looking for the points on the x-axis, so that's where the line crosses. Well, to be on the x-axis, your y-coordinate has to be 0. So to find these things, to find the x-intercepts, we set y equal to 0, because that's the common characteristic of all these points on the x-axis. We set y equal to 0 and solve for x. Similarly, it's a very hard word for me to say this morning. If we're looking at the y-intercepts, they're all going to look like 0, comma, some number. And so to find these, we set x equal to 0 and solve for y, because all the points on the y-axis are going to be 0 comma some number. So if we wanted to go sketch the graph of 3x plus 4y equals 12, we have that all those table of values a couple screens back that we could go and we could plot all those points. Well, that's all fine and dandy and legal, and we can plot points until the cows come home and get graphs. We don't really want to spend all that time doing it. With linear equations, we don't have to. We can simply, because it's a straight line, it only takes 2 points to define that line. From geometry, 2 points determine a line. So we can, if we just have 2 points that this line passes through, then we can graph those, connect the dots. So I typically will find the x and the y-intercepts as my 2 points. So the x-intercept, I'm going to plug in y equals 0. So when we do that, that means this term is going to go away because we plugged in y equals 0, and we're left with 3x equals 12, which means x equals 4. So it has an x-intercept of 4 comma 0. Similarly, if we want to go find the y-intercept, I'm going to plug in x equals 0, which means this guy's going to go away. So we're left with 4y equals 12, so y equals 3. So the y-intercept would be 0, comma 3. The x-intercept is going to be 4, comma 0. Connect the dots. And there's the graph of that equation. And if we had nice graph paper, we could go and see that all these points over here that we calculated would also fit on that graph. Like 1, comma 9/4. So it's 1 and a little more than 2. 1, comma 9/4. And everything else would fit on that graph too. Let's do another one of those to give you another example. Say we had, trying to find, it doesn't really matter. I'll just pick one. Negative 2x plus 5y equals 8. We wanted to sketch a graph. Well, recognizing that it's a linear equation, which I didn't point out in the definition, which I'm just now remembering, that you have ax plus by equals some constant c. This is, if your variables are only raised to the first power, then you have a linear equation. That's another way of finding that linear